Okay, so we're going to look at the last little section, and it's about scientific notation or standard notation. And this refers to a particular type of writing numbers, which looks like this here. So it's a by 10 to the power of n, and a is between 1 and 10. So it's a way of rewriting numbers, particularly big numbers, but also particularly very, very small numbers, in a form where it's maybe like 4.2 multiplied by 10 to the power of 3 or 4 or 5 or whatever it is. And it just means that we can rewrite the number into a number that we can kind of work with and that we can compare. And where the last part then is talking about maybe how many factors of 10 are there, or how many factors of 10 are we talking about. So it maybe lets us compare 100,000 with 3 million, 300,000 with 3 million fairly easily, because we might have 3 by 10 to the whatever and then 3 by 10 to the whatever, but we can see that they're bigger. We can see which one's bigger fairly easily. And the same thing goes with the smaller numbers then. With smaller numbers, the n becomes a minus, and we're actually going back the way. So what it means is, of course, that we're dividing, because remember from our laws of indices that if I have 2 to the power of minus whatever, so 2 to the power of minus 1, that's the same as 1 over 2 to the power of 1. So if I have 2 to the power of minus 3, that's the same as 1 over 2 to the power of 3. So how that kind of works, I suppose, for our ones then, is if we have 10 to the power of minus 4, that's the same as something being 1 over 10 to the power of 4. And we can work out exactly what that is. And obviously that's going to make your numbers smaller. So seeing how that looks then, if we're looking at this one here, we're writing the numbers in standard form. So we want them to be something multiplied by 10 to the power of n. And the something has to be between 1 and 10. So if we look at this number here, this first one, we have to stop after the 4. We can't have 46. It has to be 4 point something. So at the minute my decimal point is here, I want the decimal point to be where I've put the red line. So if I go 1, 2, 3, 4, 5, so if I was to rewrite it, it'd be 4.60235 by 10 to the power of 5. And what that means is if I take that 4.60 whatever and multiply it by 10 5 times, I'll end up with the same number I had, which was 460,235. And we could round that a part a little bit smaller as well. And we can double check it fairly easily using our calculator. And we can double check that we've done it correctly. Same thing goes with the next part then as well. I want it to be something multiplied by 10 to the power whatever, and the something at the start there has to be between 1 and 10. So if I look at this one, that would mean that I probably want to go for 5. Probably want it to be 5 point something. So if we were to make it 5.67 by 10 to the power of what? Well, we need to look at how I'm going to move my decimal point. So I need to move it 1, 2, 3, 4. And I'm moving it 4 to the right. Okay, I'm moving it 4 to the right. So for the number I have here, this is going to be 10 to the power of minus 4. Okay. And we can double check that if we're unsure of whether we've maybe gone the right way, whether it should have been a minus or should have been a plus, we can double check in our calculator and see what answer we get. And even still, the other way is to type in the answer that you're given and see can we get the same answer in scientific notation that we've come up with. So if your number is a decimal and you're writing it in scientific form, if it's already quite a small decimal, then your scientific notation will be a minus. If it's a big number, then your scientific notation will be just a positive number, just a 5 like we have here. So in our calculator, we can use this button. It looks like a times 10 with an X, so it's down the bottom. You don't need to use the power. If you use that button, you can just press that button and type in whatever the power should be, and your calculator will do it automatically for you. So looking at an example then of where we might use this, the speed of light is 3 by 10 to the power of 8 meters per second. If the sun is 1.5 by 10 to the power of 11 meters from Earth, how many seconds does it take light to reach the Earth? Well, here we're looking for time, so we need to think of our distance, speed, and time here. So we mightn't have thought that's where the question was going, but we're looking for a time, we're given distance, we're given speed. So time is distance over speed. My distance is 1.5 by 10 to the 11. My speed is 3 by 10 to the 8. And I can use my calculator to type those out for me. Okay, so I don't have to actually work those out kind of methodically for myself. And I get an answer of 500. Now we're asked to give our answer in scientific notation. So 500 would be 5 by 10 to the power of 2. So 5 by 100. Okay, 5 by 100 is the same thing as 500, is basically what we're getting at. But we want that first part, that first number, the 5 there, to be between 1 and 10. That's always how we write them in scientific notation. Okay, continuing on, we'll look at an exam question. I think we just have, we have 2 exam questions here. So first of all, the water behind a dam is normally released at a rate of 250,000 litres per second. Find how long it takes to release 1 million cubic meters of water. And we're told that 1 meter cubed is 1,000 litres. And give your answer correct to the nearest minute. So let's have a look. So the water is released at a rate of 250,000 litres per second. So 250,000 litres per second. Okay, now let's try and compare that to meters cubed. So 1 meter cubed is 1,000 litres. Okay, so if we work out kind of like we were doing before with our unit equations, if 1,000 litres is 1 meter cubed, 1 litre is 1 over 1,000 meters cubed, and I have 250,000 litres. So how many meters cubed is that going to give me? I divide by 1,000, so 250 meters cubed. So my 250,000 litres per second, so we can rewrite this as it's 250 meters cubed per second. 250 meters cubed per second. Now we need to see how many 250 meters cubed are there in 1 million meters cubed. So I take my 1 million meters cubed, I divide it by the 250 to see how many of those there are. And I get 4,000. So it would be 4,000 seconds. Okay, 4,000 seconds. Giving that in terms of minutes, then we obviously know, so 1 minute is 60 seconds. Okay, we can do it the same way if we want to. We could work out, or we just divide my 4,000 seconds by 60 to see how many minutes it is. How many 60s do I get? So I get 66. 66.6, so 0.6 of a minute. So let's have a look there. So 66 minutes and 40 seconds. So 66 minutes and 40 seconds. 66 minutes and 40 seconds, so 0.6 of a minute. Okay, for the next part, due to heavy rainfall, the operators of the dam decide to increase the flow by 10% for 24 hours. Find how many meters cubed of water were released in that 24-hour period. Give your answer in the form a by 10 to the power of n, and giving the value of a correct to 3 significant figures. So we're kind of combining a lot of different things here. So we're increasing the flow by 10% for 24 hours. So we're increasing the flow by 10% for 10% for 24 hours. So my rate originally is 250 meters cubed per second. 250 meters cubed per second. Okay, so if we want to increase that, so increase it by 10%. So we can think of that as nearly being multiplied by 110%, the 250. And I get 275 meters cubed per second. So that's going to be my rate now for this day, for this 24-hour period. And they're asking us how many meters cubed of water were released in that 24 hours. So if it's 275 meters cubed per second, well, we need to know how many seconds are in 24 hours. So 24 hours obviously is how many minutes. So we'll multiply by 60, 14,000. So 1,440 minutes in 24 hours. So 1 hour is 60 minutes. So 24 of those. And if we multiply all those minutes by 60 to get how many seconds there are, we get 86,400 seconds in a day. Okay, so I take my 275, I multiply by how many seconds are in the whole day, and I get 237,600,000. Okay, we've been asked to give our answer in scientific notation and giving a correct to 3 significant figures. So it's going to be 2.38 by 10 to the power of something. So let's see how many times I have to move my decimal. 1, 2, 3, 4, 5, 6, 7. So by 10 to the power of 7. And that is how many meters cubed of water would be released in that day at that rate if I increase it by that amount.